Yeah, what we're trying to do on this question number 92 is pretty easy. Or to calculate the mass of oxygen formed when 20 grams of KClO3 decomposes on the reaction or in the reaction based on the reaction below. Right, so now this is what you need to do here. The very first thing you have to do is consider your equation of reaction, that's for sure. And what else do we need to do? Let's quickly get the molar mass of KClO3 because we're going to use it very soon. So K is 39, and then our Cl is 35.5. Our oxygen, what's oxygen? 16. So put all that together, and when you add all that, you should get 122.5. So that serves as the molar mass of KClO3. The unit of molar mass is grams per mole. So if you're solving a theory question, you'd want to include that. All right, so what's the next thing to do? We'll get the number of moles of KClO3, and that equals mass divided by the molar mass we've just gotten. The mass is 20, and then the molar mass is this. So when we calculate that, we should have 0.163 moles of KClO3. We're trying to find the mass of oxygen formed, but first we'd need to get the moles of this one and compare it to KClO, compare it to O2. Exactly. So we can see here that from that balanced equation, 2 moles of KClO3 produces 3 moles of O2, right? So that means that if we have 0.163 of KClO3, we can actually find out how many moles of oxygen is being produced. Okay, so our x will just be 0.163 multiplied by 3 divided by 2, and that should give us 0.24489. So what does this represent? This represents the moles of oxygen that's formed. So now all we have to do is to convert that moles to mass. And we already know that mass of oxygen would be equal to number of moles of oxygen multiplied by the molar mass of oxygen, right? So you can see where this is going, 0.24489. I'm going to be multiplying it by 32. So how did I get 32? Oxygen on its own is 16, but we have O2. So you're going to do 2 multiplied by 16, and that's 32. So now multiplying that out, we're going to have 7.836 in grams. And that is our answer. All right, I'll see you on 93.